Why settle for incremental growth when you can boost your revenue, cut costs, and adopt new technology more quickly? Why navigate the complexities of AI and the complex tech projects or technology projects alone when you can have insights from the forefront runners and the innovation providers such as Glorium Technologies? What the world's leading AI and technology experts are doing right now to transform healthcare and life science organizations and drive unparalleled growth right now is what we're discussing in these podcasts. This podcast is your gateway to the answers, providing a deep dive into the world of artificial intelligence and its power to amplify your revenue, to cut costs and adopt those efficiencies that are critical to deliver patient care, especially around healthcare and life sciences. So my name is Dudley Peacock, and I'm joined by our AI and technology expert, our resident expert, Dmitry Stepanov. And welcome to our podcast, The Revenue Amplifier, AI in Action. Hey, Dmitry.
Hey, Dudley, how are you doing? What an introduction. That's actually a great one. I mean, you would say, wow, so much in one. Yes, that's actually so much in AI. That's what we're seeing right now, and that's what coming to us in the next several years. It's not just 1 or 2 months. That's a trend that we need to learn how to live in. And in order to, I guess, to learn to live in this trend, we're sharing our knowledge, we learn from our peers, and we're having this specific podcast just again to share our experience, our views in AI domain. So today we actually liked our last podcast structure. We will follow it. So basically, first half of the podcast will cover some technical issues. I mean, not too deep, just to give general idea what is what. Then we will go into some economics and specifically in healthcare. And maybe, as Dudley promised, we will cover some myth related to artificial intelligence. How about this?
Yeah, sounds fantastic. Because we last week we had a really good conversation, and we promised we're going to be talking about some of the myths, and there are a lot of them, and we want to dispel some of those myths, but we also want to maybe also add in a few things, practical things people can be doing right now to make sure they get ready for the changes that are coming. So let's go straight into it. Let's tackle our first topic.
Well, I mean. I believe there are actually, Dudley, there's a huge amount of information in artificial intelligence. I mean, so much that it's very hard to cover it, not just in 1 hour. It's probably very hard to cover it in 100 hours of presentations like this. But we will do our best, and we will just give, again, a general idea. We will focus on LLM as a technical part, specifically what is LLM, what is model, what's the data set. Maybe we will touch training, fine-tuning, and other aspects. Okay, so many people using this term model, LLM model. What is a model? I mean, in 2 words, it's basically just an array of numbers, nothing more. Literally an array of numbers. And when you say that it's 170 billion parameter models, it just means, well, approximately 170 billion numbers in the array saved in your hard drive, if it can be executed locally, or in the cloud, or somewhere. It doesn't really matter. And the only twist, I guess, these numbers are organized in a very specific way to accommodate specific architecture. And what I mean by specific architecture, you probably heard we already use this term GPT. That's basically a transformer structure that allows you to use LLM model significantly more efficient. That's actually what gave a jump start for every model that we're using right now. We're talking about OpenAI, we're talking about T5 from Google, we're talking about Llama, and many Gemini. They're all using this architecture. So there is no magic. It's literally just set of numbers, and you feed input to this set of numbers, knowing how you should handle those numbers, and you have some output at the end of the day. So that's it. So no magic at all. Very simple application, very simple libraries that can digest these models and can handle inputs. Yeah, that's basically it.
Yeah, and maybe just to recap, because we spoke about the LLM, or the large language model,
Right.
and then the transformer aspect of that, where you have all these data sets, and we're going to touch data sets next as our next part of our conversation. But you've got this immense amount of data, and I think I heard somebody call it something like a zip file. It's like somehow somebody has taken a snapshot of all available information they could get in whatever they were focusing on, create the zip file, and then the transformer, this engine, if you like, can extract information based on the way you ask a question. So in very layman's terms, a transformer really just extracts information out of a large data set or a large language model.
Well, I mean, a transformer, I mean, yes, you can say it so, and we will probably go a little bit in deep, a little bit later during this conversation, because let's keep flowing. So just, I mean, if anyone is, I guess, curious and want to build their own model, I guess I would like to give them a small warning that it's not easy and not cheap approach. Just to give you, I guess, reference and understanding. So we will. I guess I'll bring this example on based on Llama. So there are two Llama models from Facebook. One is contains 7 billion parameters, and another one contains 70 billion parameters. Okay. So just to give you understanding, in order to train
huge amount.
Yes, Llama 2 with the 7 billion parameters, which is like very small. You can run it locally, but obviously it's not very good. I mean, to some application, it's fine, but obviously one of the weakest model. You need to run approximately 180,000 GPU hours. And if you decide to do it, for example, on some cloud platform like Amazon or Azure, you would pay approximately $180,000, plus minus, because depending on the plan, depending on discount, dedicated server, and so on, so on. And accordingly, Llama 2 with 70 billion parameters is somewhat 10 times more complicated and requires about 10 times more GPU time, and therefore about 10 times more expensive. And again, those are not the greatest and those are not the best models. There are more expensive, GPT 4.5, Gemini, I don't even know. There is no information, especially Gemini 1.5, how much time they spent on this one. So again, I guess what I wanted to say, if you want to build your own model, well, I guess be ready to spend some time and be ready to spend some money. That's all about this.
I want to maybe just touch on the acronym GPU. It comes up quite a lot. So just for those that are unaware what GPU is, it's really just a PC. It's having a piece of technology is a lot like a computer, and a GPU is pretty much your PC, if you like. So when in a way of explaining GPU, maybe you got a different way of explaining GPU, because that comes up a lot when we talk about GPU hours and the capacity of the GPU and so on. Let's just delve into that a little bit.
Well, GPU, it's a graphical processing unit. So basically, there is a CPU, central processing unit, which is a central piece for any computer. I mean, like your laptop, someone's laptop, server, doesn't really matter. GPU, it's a more like a sub-processor. So it, in most of the cases, in the regular computer architecture, it sits next to CPU. But if it's a dedicated servers, I mean, they, by the way, especially very popular for Bitcoin mining, well, I mean, cryptocurrency general mining, and I mean, for the calculation, for the models as well. I mean, they just way too good for processing parallel calculations. So if you have a lot of, originally they were built to show graphics on your computers, and you have a lot of points on the screen, and you need to move around them, and you transform it. So they were optimized for those purposes. And suddenly, when you train your neural model, you have, again, a lot of links, a lot of points that you need to calculate in parallel. So GPU was actually a perfect calculation powerhouse to apply here. Well, same again with the cryptocurrency. And that's actually creates some, I guess, pressure on CPU and GPU manufacturers, and like NVIDIA and many others. So it's actually a very fast-growing area right now.
Yeah, there's a lot of investment going into GPU manufacture.
Yes.
I think initially it was very much the space of gamers or your graphics designers and all that. They would have as big a processing power from a graphical point of view as they possibly could get, and it's quite an expensive piece of kit. Obviously, with the more capability it's got, the more expensive it is. But there's such a lot of development that's happening, and I think NVIDIA, as far as I can tell, is one of the leading producers, and their manufacturers are trying to keep up with that pace. And they've had a few announcements over the last 6 to 12 months about new capacity, new production plants, etc., that they're rolling out. So it is one of those sort of big expansion areas because of the big demand that's coming for processing.
It is. Yes, and we did talk about this before, but generally speaking, after transformers were invented and GPT 3.5, well, actually GPT-2, then GPT-3, 3.5, and everybody else started to use this approach, and it was very successful, as we can see, a lot of application for LLM at this moment. Unfortunately, everybody decided that this is it. That's how we're gonna approach to LLM, and everybody decided just to scale up with GPU. So maybe there are some researches are made to make it more optimal, something else, but big companies, Google, Microsoft, Facebook, they're just scaling up with GPU time, with GPU numbers, and improving their model exclusively through the numbers of GPUs. Well, I mean, hopefully it will end at some point in the future, because it's just not sustainable. I mean, you cannot just keep growing GPU. Even so, there are, yes, as you said, there are optimizations, better hardware architectural from this standpoint. But again, it all will plateau at some point as well. So we need another quantum jump, just like we had transformers.
And the technology also has physical limits, so that they will only be able to build it up to a point where they'll have maxed out its ability, and then they will have to transform themselves. Again, just using the transform word, they would have to maybe turn into new technologies to increase the capacity and speed. But if I remember correctly, reading an article where the first few times they took these snapshots, I remember the early days of GPT-2, I think, and 3, they had taken data up to a particular date time. I think it was up to 2021 or something like that.
Something about this.
Something like that. And then you couldn't get the latest information because they'd only taken sort of early, let's call it zip file or a snapshot that you could extract data from.
Because it's for them, back then, now it's easier, but back then it was expensive to retrain your model with the newer information, because basically every time when you add a relatively big chunk of information to the model, you need to retrain. And I mean, it might not take the entire time as you spent over the previous period, but still it's pretty significant. And you actually can destroy your model if you not properly train it with the newest information. So you need to be very careful. And again, as time goes, new architecture comes up and new approaches, and old models, they become obsolete and they just start training from the scratch using new approaches. So that basically what we see right now, at least. Again, if you take example with Gemini, if you take example with GPT 3.54, hopefully 5 sometimes this year. And yes, and actually another thing, I mean, we keep touching this topic, we're talking about ethic, environmental impact, and everything else. We shouldn't forget that 2 million GPU hours, that's a significant impact to the environment, because that's a lot of megawatts of energy, and that's something that impact our Earth. So that's we cannot again just scale up without any limit.
Yeah, and there's always an impact somewhere else, and I think even these big blockchain or Bitcoin and these types of farms as they started creating, I think even for air conditioning to keep those units cool, I think they started building them somewhere in the Arctic or somewhere in the coldest places on Earth. Just so they don't have to have this extra load on the power grid, just so they can be in a colder environment to keep this processing going.
Yeah, that's actually basically Iceland is probably one of the best places, relatively cold, at least most of the time, and they have, well, you can say free energy from the underground streams, and that at least helps optimize energy consumption. Let me put this way. But I mean, it's still kind of drop in the ocean.
It is just a drop in the ocean. So let's just finalize and conclude then on the model. So let's just redefine it, and let's just conclude on that model section before we move on to the next one.
So model is something that was trained on some information. It's literally just an array of numbers or parameters, as they're called, which allows you to generate some output based on the input, nothing more than this. Okay, and the bigger the model, the better it is, because it produces better result, and we will get back to this. What's better result means.
Okay. And some models have been trained for specific purposes. So some are done for specific reasons, or some are more general, and others are more specific. Is that a true statement?
You can say so, but at least big models, like again, we're talking about Llama 2, T5, GPT, they were not ChatGPT, we actually will go, but GPT itself, 4.4, for example. They are general models, so they contain general knowledge. There are some variations, and if you will, I guess, take a look at which specific data was fed into those models, some models are a little bit skewed to public information. Some models a little bit skewed, I don't know, to coding. Some models a little bit skewing to scientific researches. But they try to keep it general, because as generic approach helps you to generalize ideas better. Once you have a generic model, you can fine tune it to your specific need. So, and that's actually what ChatGPT is. It literally fine-tuned GPT, which was tuned for the conversational purposes. That's it. So I mean, you can say, I mean, you could think that GPT and ChatGPT is the same. No, ChatGPT is actually fine-tuned GPT. Well, I mean, depending on the version you're using, and you can fine-tune it to pretty much any purpose you want. I mean, you can fine-tune it for the patient treatment. You can fine-tune it for the logistical optimization. You can fine-tune it for the administration optimization, for cost analytical purposes, for forecasting, for whatever you want. And basically, you just optimize your model to handle a specific domain and make it more focused on specific tasks, still keeping it generic.
Okay, so that's a really good explanation, because you got the large language model, if you like. It's more generic, and then it's all about what you fine tune it for a specific application, and I think that gives, I think for me especially, coming relatively new into this, it gives me comfort to know that there's a lot of information out there, and it's more about fine tuning. It's about doing the work to get the application to work for you.
Right.
Although there's a large language model available, so you can, if you have to retune it or reconfigure, there is a lot of information out there. You don't have to go and remodel everything just to make your application work.
That's correct. You don't need to create those models. You don't need to spend $200,000 or $2 million or $20 million to build your model. It is available, and it's actually available for the commercial purposes, even so it's open source. For now, because I don't know what will happen in the near future, but for now, OpenAI, Facebook, Google, they provide those open source model for commercial purposes. Again, with the limits, you cannot, there are some financial limits that you cannot go over specific revenue. But for the 90% of the company, that is more than sufficient. They will never reach those threshold that will prevent them from using from commercial purposes. And again, 90% of the companies can reuse those models for their specific purposes and fine tune for their specific workflows.
Because even if you look at the output is not endless. It's got a particular, so when you run even your chat GPT prompts and that, the output is only up to a certain point. There are going to be limits on your commercial and other use as well.
True.
Where you can't just run it endlessly, because it consumes tokens and it consumes credits and it consumes bandwidth, imagine, for these open source providers.
Well, I mean, true. I mean, if you're touching the cost of running those models, especially talking about OpenAI, for example, if you have API subscription for the OpenAI, I mean, it's relatively cheap when you just chat. But once you start doing some serious stuff, analyzing text, multiple PDF, multiple documents, and summarizing them and doing it on the regular basis, those prompts, they add up. And I mean, you can talk about tens of thousands monthly fees easily if you're using it actually for some commercial and high scale purposes. Running your local models is not free, just again to be fair. Depending on the model you select, it can be pretty impactful from the point of using GPU power, because GPU are required not just for training, but for running those models. But obviously, running models takes 100,000 times less energy comparing with the training. So it's not free. Nothing is free. You still need to pay. Yeah, but I mean, you just need to compare, I guess, the scale of the data you're feeding to the model, amount, the size of the model, and take it all into consideration and see what's the best approach. So that's something that I guess experts can provide information and can advise what's the best approach.
It comes back to the use case again. It comes back to, use it for where it's most valuable, and you can't just use it for everything. It's being specific and being focused in the use case.
Yes, that's correct. That's correct. And I mean, again, if you're talking about use cases, well, I mean, there are a lot of applications, there are a lot of wrappers right now. You're talking about chatbots, for example. I mean, there are a lot of products that that's probably one of the biggest low-hanging fruit that a lot of companies are selecting, implementing ChatGPT type of chatbot. And there are a lot of frameworks that allows you to do this. And again, what we've seen in our experience, sometimes we just recommend you don't need to build your custom solution for now, because you have 2 or 3 customers, and just to test your business ideas, go with some framework, implement it, use it, pay them extra fees comparing with a custom solution. And if it's work out, if your business scale up, come to us, for example, or come to other company and build your custom solution that would reflect the same, but with a more specific approach, with some nuances and so on, so on. So Dudley, there are so many options right now that sometimes we got kind of behind a week or 2 and need to catch up with the new concept, with the new solutions and so on, so on. And I
It's
mean,
amazing how fast it does
it's
move. It
it's
really,
crazy.
absolutely
It's crazy.
crazy.
Yes. Like we're using something new, and then suddenly somebody tells us, "Hey guys, I mean, like last week there was like significantly better approach to solve this." Oh yeah, we missed it. Okay, yeah, we'll start using this, or we recommend someone like this. So and I think I see a lot of people, a lot of companies are sharing again this knowledge. Nobody is keeping it inside. Well, as long as it's not copyrighted or not under NDA. People are talking about it, and we are talking about this, and we always are open to provide any information, because even when we talk and when we share our information, sometimes we learn something new, by the way. That's actually interesting as well.
Yeah, I just remember my when my kids were teenagers, they used to say, "It's so last year, Dad. It's so last year." Now we even talking about it's like so last week, and then
Yep.
it's going to be so yesterday. It's happening so fast.
Well, I think it has its limits. I think it will stabilize at some point, because
We hope.
it's too tiresome, Dudley. I mean, for us to keep up with all these technologies, it takes a lot of energy. So, and for people who doesn't know this and doesn't understand and do not have some previous information, I cannot even imagine their feelings when they'll keep learning and like, let's wait for another week and we'll reconsider, and then next week something new. Guys, I just digested what we were talking about last week. Something new. What are you doing to me?
Yeah, so just coming to a practical point of view, so organizations, healthcare, life sciences, and any business or any kind of organization,
Right.
They themselves must feel incredibly overwhelmed. I mean, they've got their day jobs, they've got people working in the organization, you've got the decision makers, you've got the management teams, you've got the tech teams, etc. They're already busy. Now imagine they still have to add this additional workload of bringing in new technologies, staying ahead of the curve, but also being concerned about competitors or competitive forces or things that are coming in that could completely negate all their hard work they did today, because next week there's something that has literally removed the purpose of whatever they were working so hard on. So I imagine from a just an everyday organization, people within organization must be struggling and must be quite overwhelming for them.
They are. And I mean, they're not just struggling. I mean, they actually are so behind in understanding and so concerned hearing all those myths, all those failures and everything else. And they sometimes reluctant to actually get into this area when the solutions, I mean, all the problems are solved a long time ago. And obviously there are some new problems always popping up. But previous one, everything is solved with technology is so far ahead. I mean, you can translate the text to speech technology is so much better. Speech to text technology is so much better than it was in the fall, for example. And businesses, they just very frequently don't understand potential or solutions that AI can offer them now. And I'm not talking about what's going to be in the this spring or this summer. And I mean, companies do not release something like this in 2 months. It's the bigger company you have, it's what is it? Budget planning, budget approval, budget allocation, resource planning, resource allocation, design, development, and then maybe deployment, right? I mean, I skipped multiple steps here, but I think without those multiple steps, skipped multiple steps already more than enough. And I mean, you're just thinking about implementing something now, and you probably will release something in the summer or fall. Maybe when majority of your competitors already will have something in their system, and they will be pitching it and they will be selling it better, their revenue will go up, and that's actually Dudley, very interesting. If you take a look at the company who are involved in artificial intelligence, and we're talking about the entire stack, I mean, from NVIDIA, for example, who produces GPUs, to any other company that are involved in some frameworks or in solution AI, you see 2, 3, 4 500% growth over the past year. I mean, not everybody, to be fair. Sometimes it's a 10, sometimes it's a 20. But pretty much the entire stack of the companies who are involved in artificial intelligence, they're growing like crazy. And I mean, we don't know how long this trend will last, but it's still lasting. And the trend is definitely going up.
Yeah, it's very difficult to predict, and I think the difficulty is when do you get in? It's like, when do you get involved?
Yesterday.
And my
Yes.
thinking is you get as quick as possible. But
Yes.
if you sit and wait, it becomes obsolete very, very quickly. Anything you're doing right now could be obsolete in a very short space of time.
That's actually one of the reasons that company kind of waiting for something, but that's wrong approach, because in the most of the cases, the architectural approach to those solutions, you're talking about generative or predictive AI, chatbots, image processing, text processing, speech processing, all this stuff from the underlying wrappers around those pieces, they're gonna stay for a relatively long time. I mean, not forever, obviously, just like any other technology. But replacing one LLM by another LLM, oh, I don't like Llama, I want T5, just like this. I don't like T5. Oh, OpenAI made GPT-5 open source. Sure, I'll just replace the model. Replacing the models is very easy. It's extremely easy. I mean, obviously, it will require some testing, verification, making sure that you probably, if you were fine-tuning your model, you need to re-fine-tune your model with a new piece. But it's all manageable. It's not like end of the world, and you're gonna waste a lot of money. If you take pretty much any technology, like with the databases, so databases are to some extent obsolete. I mean, it's data warehouses. You must have a data warehouse if you have more or less sufficient amount of data for reporting purposes, for sharing your data with the third parties and everything else. But I mean, we're still using databases. It's still in the core of the application. It's still using it for the business logic. And data warehouse are just extension. And I'm sure that there will be something else on top of this. So it getting old, but again, it's not wasteful old. Let me put it this way: it has a very high level of reusability or recycling from the investment standpoint.
Yeah, I recall years back when especially when you're talking about, when we go on, our next topic is about data sets and databases, etc. So even that move from having a database, and they used to do calls on the actual database directly, the bigger the databases got, the more difficult those calls were. So then you needed the data warehouse, and you needed these meta layers that would extract and make sense and make the data set smaller. So that if you're doing any calls, and when I talk about a call, it's like, say, running a BI, a business intelligence report, where you're trying to do some forecasting or some historic analysis or something like that. In let's call it the old days, and this is not so long ago, where you had an Excel spreadsheet and you tried to run a few formulas and so on a few sheets, and sometimes you'd press go or refresh, and then you have to walk away, and then maybe a few hours come back, and then your model is complete, and then obviously things have gone on a little bit now. Now it's the processing power has gone up, and the technology has improved. But that same concept is still there. You still need your base data to a large extent before you can start processing the data. So maybe just talk around that a bit.
Yeah, sure. Well, I guess data set, from the term of artificial intelligence, and specifically, let's put it for LLM, it's a basically set of, well, text, images, videos, depending on what you're using to fit your model for training purposes, that are used for training, for verification, and for testing of your model. Same applies to fine-tuning as well. I mean, you need your own set of data, again, for fine-tuning, verification, and testing of your fine-tuned data. So generally speaking, it's just some text. For example, for OpenAI, well, I mean, like most of them, the biggest models, they used almost entire web content to train their model. Obviously, they were filtering it out, cleaning, and there are multiple approaches to do this to prepare your data set. But generally speaking, data set is some set of human readable, seeable, I don't know, feelable in some way information that can be fed to the model, again, for training and for fine-tuning purposes. And as you mentioned it, obviously the bigger, the more general or generic you want your model to be, the more information you need to feed into your model. And but then again, GPU time goes up, cost goes up, size goes up, and actually the usage of this model from the GPU standpoint, it goes up as well. So it's everything grows proportionally. But there are a lot of models right now. They're relatively small. You can run them on your computer, on your cell phone, and I'm pretty sure that it will get even smaller and smaller as technology will grow. So it's just an originating source, I guess, of the information. That's a data set. And again, if somebody is thinking about building their own model, there are right now public data sets that can be used for these purposes. I mean, there is a Common Crawl data set, the Pile data set. Is basically literally almost entire internet that was fed into those data sets, and people can use it. It's a public, also open source, publicly available data sets that people can use. But again, think twice before you start getting. I mean, by the way, one of the pieces when we're talking about cost, we didn't talk about people who will handle this. That's an expensive resource as well. Let me put it this way: very expensive. So. And I think, Dudley, let's wrap up with our technical part. We spent a lot of time. The only piece that I guess I would like to quickly cover, it's well, fine-tuning types. Again, this is a practical, I guess, question. You can fine-tune in two ways: hard way and easy way. The hard way is what we have discussed. You prepare your own data set, which is tailored for your specific task. Now, again, it's diagnostic, image processing, video processing, billing, invoicing, doesn't matter what it is. And you fine-tune your model using this data set. Another one is somewhat cheating, right? It's called prompt engineering. So you take a generic model and you literally create a prompt for this model that describes how this model should behave. You're describing it, limits, what it should, what it shouldn't, where specifically it should focus on, maybe some frequently asked question information that would be fed to this prompt, and the model will use this prompt. It can be pretty large every time, or creating a session, or for each session. It doesn't actually depends on the implementation, and it will give you, I guess, a good result. Quick comparison. So fine-tuning using dataset is more expensive, but significantly more, it has significantly higher performance comparing with the prompt engineering, because with the prompt engineering, it's basically every time when you make a request, this entire piece needs to be jammed into the model, and model will use this prompt not very efficiently for the purpose of answering the question. But it's a cheap. So you literally just create this prompt. If you need to change something, you make the changes in the text file, and the next request will be fixed. With the fine-tuning, once you fine-tune your model, this is it. You make a mistake, you better retrain your model from the scratch, which is another set of the expenses. Okay,
Yeah,
so
I want to maybe just then before we go into some of the myths, I want to maybe just say maybe next week if we could cover. I mean, you spoke about people,
yes,
being expensive, and you also spoke, because I think a lot of people that may be watching this podcast and saying, okay, what happens to me personally, like from my point of view? I mean, I'm in a particular role. What do I need to learn? Because some people, if I take people that I know, the youngsters are saying, I'm learning to do coding. This is my career. Or some people are saying, oh, I'm going to be a prompt engineer. Or what does that mean? I mean, maybe we should touch on some of the career choices for especially the younger people, or people that are thinking about what do they do next once their jobs, and they might be realizing their jobs, or parts of their jobs, are becoming obsolete.
well,
What's the pathway? And maybe we should leave that as a cliffhanger for next week, so we get people to watch next week. But you can answer quickly if you want.
yeah, let's keep it as a cliffhanger, I guess. That's actually one of the topics in the myth, and we will skip it, I guess, to keep it mythical. But yes, we will cover it next week, and because this is a big topic, this is a topic by itself. Again, it's not just technology. It's not just answering a question to business owners, to companies. It's actually addressing much bigger issue about ethical issues, about jobless issues, about where exactly we're going as a society. And I think we need to dedicate at least, I don't know, at least 10-15 minutes just to kind of go through all those aspects. Okay, because
yeah, and there's another thing I want to think maybe for a future episode as well, and that's the transition we've seen, and that's the big debate between product off the shelf versus develop yourself. And you did touch on it briefly, as in the data sets and so on. And if I code and I get this data set working specifically for my use case, it's far more accurate. But if you're doing prompt engineering and other things, and you're doing prompting, you can take a general data set and make it do, at least up to a certain level, do a particular amount of accuracy. So you're almost starting to see this type of thing starting to settle in. If I remember over the last sort of 15, 20 years, or even 25 or 30 years, when PCs first came out,
right,
you had that was the next big thing, wasn't it? Everyone was going to study university, whatever. It was all about coding, and it was about whatever the language of the day was, and so on. And a lot of that's changed. A lot of companies would prefer off-the-shelf product, already developed, just plug, play, and configure, theoretically anyway. Then there's more of a user adoption, etc. And then the provider or the vendor of the software would update, versus in-house development. And then how do you keep that alive? And we must keep that for a future episode as well, because I did see this week on LinkedIn this big debate starting to happen between off-the-shelf versus in-house developed. And I see people already starting to have that and it's starting to get quite heated, I must admit, the debate between the off the shelf crowd versus the in-house development crowd. And it was interesting to watch as we move through the phases. So let's tackle that one as well at some stage.
Sure. Yeah, absolutely. That's another interesting topic.
Yeah.
So
shall we tackle some of the myths?
yeah, let's talk some of the myths. So one of the things, I guess, people think that AI can think like a human. So basically process information like a human brain. But the thing is, artificial intelligence systems, they process information based on the data and algorithm. So they don't have consciousness, they don't have emotional intelligence, and thinking is totally fundamentally, I would say, different from human way of thinking. So one person actually was giving an example about this. that he started to feel when he talked to some chatbot that it's almost like a human, right? But he said, well, I went to the business trip for 2 weeks. I came back and my computer was still on, the session was still open, and my chatbot was patiently waiting for my next question. So no, it's so I mean, like we need to remember about that. This is just a machine. I mean, it's just emulates to some extent our abilities, but nothing more, at least for now. Okay.
I just smile at that because I don't know if you have Alexa or one of those types of things. We use Alexa, and I know my wife, what she does is she speaks nicely to Alexa. It's Alexa, please,
Oh
and
yes.
thank you, Alexa. And I'm like, I don't feel the same, but because Alexa speaks so nicely back, and it's and is very, very polite, it's almost like yeah, I see even with promptings, people have a, please can you create this whatever, or thank you.
Oh, come on, Dudley. It's a good habit. It means that you did a great job. so so
So, but it
nothing
is,
nothing wrong
you
to
can
say
think it's human.
please and thank you one more time to someone or to something.
So at least the courtesy is still there, and you do
Yes.
feel compelled, especially if Alexa or whatever is asking you nicely. And I mean, even Siri, and I even ask Siri sometimes to tell me a joke, and it tries to tell me a joke, and then I say that's not funny, and then Siri then gives me another answer. So, and then sometimes you think that's just normal banter, but it's not. It doesn't have a personality.
Well,
Very
yes,
interesting.
that's it. The
That's it.
next one, actually, an extension of this myth that AI can surpass human intelligence at some point. So there is even such term as AGI, IGA, sorry, artificial general intelligence, and that's basically that term which basically describes the level of the artificial intelligence which is similar to human. And basically, I mean, there are obviously rumors, so I don't support them, but that's actually why Musk started all this legal battle with OpenAI, because OpenAI, they have some breakthrough with AGI, and they have something very powerful in their hands. And as you can probably remember, OpenAI was originally opened as a more educational open source platform, which was then converted to the commercial. So we probably will get in there, but those are just rumors, because in order for artificial intelligence to reach this specific goal, I guess, there are a lot of technologies that needs to be invented, and they are not known, at least to the general public as of now. So maybe something somewhere is getting closer, but not in the foreseeable future.
Yeah, because
Okay.
there's a lot of movies and sci-fi and so on where movies are predicting that you got the singularity, and you got this thinking,
Yeah.
it sort of takes over the world and starts thinking for us, and so on. So I mean, what you're saying is it's it's not that it's impossible, but it's at this stage it's not likely or possible.
Yes. And that's actually, I guess, leads to another myth that AI has its own intentions. So that's actually AI will destroy us, they will kill humans, and so on, so on. Well, I mean, let me put it this way: I don't know how AGI will be, because that's something we don't know too much about. But at least in the current way, how AI is built and how it behaves or think, as we have described it, no, it cannot have its own intention, because artificial intelligence operates based on the algorithm and objective that we set for them. And I mean, we're talking about model that we build, we're talking about prompt that we feed to the model and to the algorithm. And your artificial intelligence does exactly what you basically build it for. You can build it for some bad purposes. I mean, for military, I guess, for something else. But again, it's not AI who has its own intentions. It's a human who programmed it, who built it for the specific purposes. So it cannot have its own desires, its own motivations or intentions. It literally reflects, again, algorithm and objectives that were set for this model. So I guess this myth is busted. Okay.
Yeah, and then the other one is the decision making side of things. So will we have something that decides for us?
Well, it can assist in decision making by providing some insights, I guess, based on the data analysis. But a critical decision that is what is actually required, that is still requires still, I'm using still, okay, because I mean, we don't know what's going to be in the future, but it still requires a human judgment. It still requires some ethics, accountability, areas where basically artificial intelligence cannot replicate human capabilities. So we are far, far, far away from what humans are capable from the judgment and from decision standpoint.
Not that humans can actually make good decisions either. So, so I mean, we're comparing an imperfect world with an imperfect.
Yeah, well, we're comparing imperfect world with impossible world, I guess. So it's it's incomparable things to some extent.
Because I recall some of these TV shows where they these behavioral psychologists and that they predict sort of partners. So if you can partner like man, woman, and so on, they say that characteristic will work well with that characteristic, and the probability is potentially better than they could decide for themselves. So humans don't necessarily always decide well for themselves, where even other humans can probably make better decisions on their behalf because they're not maybe emotionally attached. And maybe those are the augmented things that can happen with AI. It could help sort of get you more, I don't know, what's the word, more practical in your decisions as opposed to emotional or I don't know.
Well, that's actually, I mean, I guess I'm gonna jump in off topic here. That's actually one of the problem of the artificial intelligence, and what we're seeing right now, that some models are trained on the information that was generated by another models. And for example, that's for image processing. So a lot of, well, that's a topic for the next conversation about job, how AI affects the job. But for example, no, we will cut this section. That's a way too much topic. So we will remove this one. Forget about this. What would be the next myth we want to take a look? Did we replace? Well, AI will replace all jobs. We will touch base it during our next session. AI is always objective. AI is as objective as the data set you fed to the model for training and for fine-tuning purposes. That's a short answer. So AI cannot be good or cannot be bad. It's literally just you feed the data and AI will behave according to this data. That's it, very simple. So it cannot be objective or subjective. It's just reflects the data. Okay.
Reflects, yeah. It definitely does.
Yes. Anything else we missed from the
Well, I
list?
just maybe just one last thing we should just touch on before we close off, and that is just a practical application. So we spoke a lot about some of the more theoretical. We spoke about some of the myths. If you could think about like today's discussion, and we look at the healthcare and life sciences environment, maybe just one golden nugget that we could share with whoever is joining us today, and they from that environment, what can they take from today's conversation?
Well, we did cover generative artificial intelligence during our previous session, shortly at least, and I think it would be fair to touch predictive artificial intelligence in healthcare, how exactly it affects, I guess, economics of the industry, and it's a pretty big list where predictive AI, and we'll just touch based, I guess, few of them. One of the good examples, I guess, it's a disease prediction and prevention. That's basically where artificial intelligence analyzes the patient data, analyzes patient records, and predicts, I guess, the risk of developing certain diseases or certain conditions such as diabetes, cancer, heart disease, and basically allow early intervention, for example, to treat those diseases. And the impact obviously is here that it helps to provide diagnostic quicker, takes less time from the physician standpoint, I don't know, specialist standpoint, capacity, equipment testing, and so on, so on. So you immediately can see cost reduction because you don't waste your resources on something that doesn't need to be done, and revenue increase because you can process more patients and provide more services to the bigger population. Okay. Another one is hospital and patient management. So basically, artificial intelligence, predictive artificial intelligence, can predict admission rate, can optimize staffing at the hospital, allocation of the people between departments, dynamics in different departments, improve patient flow and care in the hospital. And again, from the economical standpoint, you have more patients, you don't have less vacancies, I guess, if you can apply it to the hospital beds, more proper and more even load to the equipment, proper equipment in time, so you don't have extra equipment in your hospital, but you can provide appropriate service to your patient. So it's just, you touch pretty much any area of the healthcare, and you can apply both, to be fair, generative and predictive AI in the optimization. So it just, I guess, a matter of funding, time, desire, and I guess to be bold and move forward with this new technology and be ahead of everybody.
Be ahead of everybody, and I think and keeping pace and being wise about it, and not waiting. I think that's the whole thing, is at least start educating yourself, start getting involved, and start seeing where you could apply it. And to use a cliche, is should be a lot of low-hanging fruit out there that you can quite easily, at a very low cost, you can get AI working for you and reduce mistakes, increase sort of speed and efficiency, etc. And make your people that work within those environments, make them even happier, and more productive, and feel like they want to be not just the drudgery of the day, but AI can remove some of those steps.
I mean, to be fair, and again, you actually touched a lot of, I guess, very painful topic about, again, job, right, related to AI and how people feel. So there is a way to solve it in the positive way. in the constructive way that will positively affect everybody, not just businesses. I mean, we've done it in the way when every single person in the company were happy with the implementation, with the introduction of artificial intelligence in the place. So we as a company trying to be sustainable from many aspects and trying to push for solutions that satisfies, make our society better in general, not just optimizing cost here and increasing revenue here, which is important piece of the business development. But again, I think especially nowadays, everybody started to understand that we need to solve a bigger problem at the same time without significant impact to the businesses. And that's where I guess companies like ours are ready to provide any information, any consultation, to remove any concern or any questions related to the artificial intelligence.
Well, Dmitry, was a great conversation. We've hit the hour, so
Yes.
Thank you very much. I've learned a lot again, and looking forward to next week.
Yes.
We left a few cliffhangers, so we're going to be touching on that today. We covered quite a few technical aspects, also the myths. So I just want to say thank you to everyone for joining us today, and I hope today's episode really just gave you that extra edge, the additional information, maybe just got you inspired a bit to start looking into AI and how it can help you and how quickly it can help you if you've got the right people and the right team involved, and even just a few of the insights, start applying them. So if you're looking to leverage AI in your business, or if you're looking to learn more about its potential, can I invite you? I'd like to invite you to reach out to Glorium Technologies, to Dmitry and his team, and really tackle really a conversation. Start having an open conversation. There is an opportunity to have a briefing where they can come in and just share some ideas, some quick wins that you could have. And again, it's probably a no obligation thing, Dmitry.
Yeah.
So in our discussion, we could go through a whole lot of things, just like we're doing now in the podcast itself. But in those discussions with you in your boardrooms, in your teams, I'm sure Dmitry, Glorium Technologies can handle quite a few questions that you might have that are not yet being answered, or that you want specific answers for. And I'm sure that they can, as a team, they can pinpoint your challenges, can reveal how AI can be your ultimate amplifier. And we talk about revenue amplification, reducing costs and wastage, and really just making an environment that's a lot better and easier to work with. So please don't hesitate to contact us. Please click the link or the link below and go and have a look at what Glorium Technologies can do, but also just subscribe to the channel, give us a like, and share with others if this is of interest to you and this has been helpful. Thank you very much for joining us, and see you next week.
See you next week, guys.